Okay, so today what we're going to talk about is a really important concept in economics, and it's keeping your eye on the margins. And specifically, what we're going to do is we're going to delineate the difference between what we can call the marginals, the totals, and the averages. Okay, and this is something that a lot of people, but a lot of businesses as well, fail to apply this simple insight, and it is kind of the mark of what it takes to be a good economist is keeping these three things in mind. Okay, now averages are very easy to think about, but marginals are much more important in the sense that they provide us with a lot more information that's actually relevant. Okay, so let's kind of dive into these things. Okay, so the marginal is going to be the change in the total due to including one more unit. So we can think about marginals as the change or the delta in the total as a result of including one more unit. Okay, so let's do kind of an example here. Okay, so let's say that you take a test. Okay, so we'll make a little box here, and you take one test. So we'll call this test number 1. Okay, and we're going to look at the marginal, the total, and the average. Okay, and this just comes from, I should point out, page 97, table 7.1. Okay, so on your first score or first test, let's say you score an 80. Okay, so you have 0 points at the beginning of the semester. You increase, you get an 80 on the test, so your score has increased by 80. Your total is 80, and your average score is also going to be 80. Let's say you take a second test, and on that score, or on that test, you score an 86. So your total score goes up to 166 out of 200. Your marginal score is the score on that test, and your average is just the average score. So we would add the 80 and the 86, or we could take the 166 and divide by 2, and that would give us 83. And finally, let's say you take a third test and you score an 89 on this one, and that gives you a total score of 255 out of 300, which is an average score of 85. Now, as you can see, if your marginal, is greater than your current average, then your average is going to go up, right? So here, the marginal score of the second test was greater than our average with just one test, and so our average score increased. We could look at, the 89 versus the average of 83. 89 is bigger than 83, and so our total average score, our overall average score, is going to continue to go up. Okay, so this gives us kind of a rule that we can follow, that if the marginal is greater than your current total, your current average, then average will increase. Okay, if your marginal is less than your current average, then the average will decrease. Okay, so pretty simple stuff so far. Okay, so let's do kind of another one. So let's talk about chairs, and this also comes from page 97. This is table 7.2. Okay, so let's say you're making chairs, and we'll call it chairs per day. Okay, if you make 1 chair per day, it costs you, so we'll call this the marginal cost. And then we want to look at total cost. And then we want to look at average cost. Okay, so if you make one chair per day, let's say that that chair costs you $100 to make. So your total cost is going to be 100, and your average cost per chair is also 100. Okay, if you made 2 chairs per day, the marginal cost of the second chair. Let's do this. If you make 2 chairs per day, you could make 2 chairs for a total cost of $180. Okay, so if the marginal is the change in total cost, then the marginal cost of the second chair is only $80. And this brings your average down to 90. Okay, and then let's do the third chair. Okay, so if it costs you, let's say $285 to make 3 chairs in one day, well, then that means the marginal cost of the third chair would be $285 minus the 180. Okay, I'll get rid of that dot, and that would be equal to 105, and that's actually going to increase your average cost to 95. Okay, so everything we just talked about here is still accurate and still applies, right? If your marginal is less than your current average, then the average will go down. And if your marginal is greater than your current average, then the average goes up. Now, let's apply this to perhaps revenue. Okay, so this comes from page 98. This is table 7.3. Okay, so let's look at, again, chairs, and this time sold per day. Okay, and then we've got the price that we can charge. We've got the total revenue. We've got the marginal revenue. And then we've got the average revenue. Okay, so we'll just make a quick table here. Okay, if you sold 1 chair per day, let's say you could charge a price of $110. So your total revenue is 110. Your marginal revenue, since you had no revenue when you sold 0 chairs per day, your marginal revenue would be equal to 110, and your average is also equal to 110. If you sold 2 chairs per day, then your price would be decreased to 100. Okay, this means your total revenue, which is just price times quantity, that would be $200. And this means your marginal revenue from selling the second chair is only 90, and your average revenue is 100. Now this part here usually causes some difficulties, because I sold the second chair for $100, but my revenue only went up by 90. And why is that? Okay, well, the reason is because if you're going to sell 2 chairs at $100 a piece, that means you're losing $10 on the first chair. Okay, so you now sell that chair, which you used to sell for $110, you're now selling that chair for $100. That's a $10 difference, and so that accounts for the $10 difference between the marginal revenue and the price. And if you sell a third chair, let's say you could sell 3 chairs per day at a price of 90, that would give you a total revenue of 270. Your marginal revenue is just 270 minus 200, that's equal to 70, and your average revenue would be $90. Okay, so again, here we have a change or difference between the marginal revenue and the price, and the reason why it's $20 difference is because now we're lowering the price by 10 on 2 different chairs. On the first 2 chairs, right, and 2 times 10 is going to be 20. Okay, so let's apply this to the real world, and let's say that the average cost per life saved from, let's say, airbags is equal to $1 million. Okay, so in other words, it takes $1 million worth of airbags installed in cars to save 1 additional life on average. Okay. Now this might seem a bit weird, but think of it this way. How many people get in accidents where having an airbag was the only reason that they survived the crash? Well, the answer is probably not that many. And so it's going to take a lot of airbags to save 1 life. So $1 million per life saved might not be too bad of an estimate. And let's say, but by contrast, the average cost per life saved from seatbelts is equal to only $500,000. Okay. Now, let's think about this. Would greater safety be achieved more cheaply by spending more money on airbags or seatbelts? Okay. And you might intuitively be drawn here because, after all, the average cost per life saved from seatbelts is only $500,000, and the average cost per life saved from airbags is $1 million. But we actually have no way of knowing the answer to this question without knowing the actual marginals. So we need the marginals to answer this question. Okay. We cannot answer this question without knowing what the marginals are. It could easily be that we need to spend another $2 million on seatbelts to save 1 more life, and that we'd only need to spend $1.1 million on airbags to save another life. And given that we're trying to save the most lives with the fewest number of dollars possible, if the above, or if these numbers were accurate, then we should buy the airbags, even though their average cost is actually higher per life saved. Okay, so now what I've done is I've just recreated a table from the book. Okay, so this comes from chapter 7. This is somewhere in the middle of chapter 7 here. And what I want to do is walk you through how to calculate all these marginal products and these average products. Okay, so what we've got here in the leftmost column, right? So here in this column, what we're talking about are the units of labor. So you could think about these as the number of workers. Okay, the total product here in the second column, that's the total amount of output that these workers are able to produce together. Right, the marginal product is still going to be the additional product that the next unit of labor is able to provide. And then the final column, the average, is just the total product divided by the units of labor. Okay, so if we wanted to calculate the marginal product of the second unit of labor, okay, what we would do is we would look at the total product with 2 people, and compare that to the total product with 1 person, and we could see that it increased by 10. If we wanted to calculate the marginal product of the third, right, we would take the total product of 3 and subtract from that the total product of 2, and that gives us a marginal product of 8. Okay, and then I'll just kind of speed through the rest of them here. So this would be 6, 4, 2. Okay, now notice when we get to the 7th unit, the total product actually did not change at all, right? The total product with 7 people is equal to 36, and the total product with 6 people is also equal to 36. And so the marginal product of the 7th worker is 0. They add nothing to the bottom line. Okay, and then notice with 8, the total product is actually starting to decrease because we produce 35 with 8 people, and we produce 36 with 7. So that means our marginal product would be equal to -1. Okay, and then average is a pretty straightforward thing to calculate, right? I'll just fill in the column here real quick. So this would be 8, 8, 7.5, 6.8, 6, 5.14, and 4.375. Okay, so here's kind of what we might think about, right? If we're going to think about hiring additional people, we might want to think not just about the total amount of output that the team can produce. We might also want to think about the marginal product of each additional person. Okay, so we might say something like, if you can hire these people for $4 or whatever per some unit of time, then you want to continue hiring people until the cost of hiring them is equal to the additional benefit you're going to receive. And so in this case, you would hire 5 workers because the marginal product of the 5th worker is 4, right? And that's the same in this hypothetical case where workers cost 4, whatever these units are. Okay. And so this allows us, understanding this marginal product allows us to apply a very, very important principle in economics. Okay, and that principle is what we call the equimarginal principle. Okay, and the idea behind this is that what you're striving to do is equate the marginal rates of return across opportunities in order to maximize total revenue. Okay. In other words, what should be true in what we could call an equilibrium would be the marginal payoff should be equal across opportunities. Okay, so let's do a quick example. So what we're going to suppose is that there are 2 games or 2 casino machines, if you want to think of them this way, that you could put tokens into. And if you put a token into the game, it will literally just give you money. Okay, so you have these token machines, right? And there are 2 of them, A, and we'll call the other one B. And if you put a token into either of the machines, you just win money. Okay, now the amount of money that you win or get depends on how many tokens you've already put into that machine and which machine you've already put that you're putting the token into. And let's say you have a max of 10 tokens. Okay, you have a maximum of 10 tokens and you have 2 machines, A and B. Okay, so I'm going to use the magic of editing here to just put the payouts on the screen real quick. Okay, and we're back, and I've put the payoffs on the screen. So if you put the first token into, or rather I should say the first token that you put into machine A will give you a payoff of 20. Okay, the first token that you put into machine B will give you a payoff of 15. Okay, and remember we have 10 tokens. Okay, and so let's just think about this sequentially, where we're going to go. Okay, so with our very first token, we can either put it in machine A or we can put it in machine B. Okay, and so given that 20 is bigger than 15, we would predict, or we would understandably put our first token into machine A. Okay, so now we take our second token and we have to decide. So I'm just going to mark what we do here. Okay, so we put one in column A, or in machine A. Now we have our second token, and we can take our second token and again we can put it into machine A or we can put it in machine B. Now if we take our second token and put it in A, that would be the second token in A, and we would get a payoff of 18. Alternatively, we could put the token in machine B, and that would be our first token in machine B, which would give us a payoff of 15. But 18 is bigger than 15, and so we should put our second token in B. Okay, so let's mark that that's what we did. Now, once again, we can take our third token, we can put it into machine A and get a payoff of 16, okay? Or we can put it into machine B, which would be the first token. Sorry, I screwed this up already. I should be writing an A here, okay? So we did A, so we did 2 in A. Okay, now we can take our third token, like I said, we can put it in A again, get a payoff of 16, or we can put it in B and get a payoff of 15. 16 is bigger than 15, so we should go with A. Okay, so we've done A again. Fourth token, we can get 14 or 15, so this time we go with B. Okay, so that gives us this one here. We can have, with our fifth token, we can put it in A for the fourth time and get 14, or we can get 14 and a half by putting it in B again. 14 and a half is bigger, so that means we should put it there. Okay, so let's mark that. With the sixth token, we can put it in A and get 14, or we can put it in B and get 14. Either way, doesn't really matter which one we do. We should be indifferent to this. So we could pick either one, totally fine. I'm going to pick, in this case, A, since that's just as good. So let's say A. All right, and I'm going to leave that one red just because we can come back to it. Okay. Now we have the option between 14 and 12, right? So that would be our seventh token. We're going to pick 14 over 12, so that means we're going to go with B. We have our next token. We can have 13 and a half or 12. We should pick the 13 and a half. That would be this one. Okay, so that's 8 tokens so far. And then we can have 13 or 12, so we should pick 13. Okay, that's that. And then we can have 12 and a half or 12, and we can pick B again. Okay, and so what we see here is the sequence that would yield the maximum amount that we could possibly get from playing this game. Now, obviously, we could, if we wanted to, reverse these two coins right here because they were the same payoff either way. They were both 14. So we could do that and it wouldn't make any difference. But the overarching idea here is that the revenue maximizing allocation of tokens would be to put 4 in A and 6 in B. Any combination other than that will yield smaller amounts of actual payoff or total payoff. Okay, so here the marginals, right? So the marginals at the end were 13 and 14. Okay, and so the marginals are as close as we can possibly get them given this game where we have the constraint of spending 10 tokens. Okay, now obviously they were equal with these two here. Okay, but that was not going to satisfy our constraints because we still had extra tokens and those tokens had positive values. Now, if we looked at averages, okay, which the book goes into, the average return with a fourth token into machine A would be 17, and the average with one token in machine B was only 15. Despite this, it makes sense for us to continue putting tokens in B instead of A, even though the averages were the opposite of what we might think. Now, equalizing marginals is applicable to other areas as well. Okay, so for example, suppose you have 2 factories jointly owned by the same company, producing the same product. Well, what we should expect is that each factory will operate at a rate of production that minimizes the cost of total production. Okay, so we want to minimize total production costs across both factories. Okay, In other words, we won't in other words, we won't produce at one factory at a higher marginal cost than we could at the other factory at a lower marginal cost. Okay? Regardless of what the average costs are across both of these factories. Okay? This is why sometimes businesses will expand production in one area even though the average cost of production is higher there. It's not the average that matters. It's the marginal that matters when you're actually trying to either maximize revenue or minimize costs.